Salutations, celestial sightseers. I'm David Fuller. Welcome to Eyes on the Sky. What's up this week? Well, I promised that we would start looking at some galaxies, and I have a couple for you that you can start looking for. And the part of the sky that we're going to look in is towards the southeast if you're in the northern hemisphere. And as you can see from this particular graphic, well, we've got all those winter things heading off there towards the southwest and kind of in the south. So this way to the southeast, we have Leo the Lion. And we pull up our constellation shapes, we can see how Leo is right here. The bright star of Arcturus is going to be off towards the east. That's going to, you arc to Arcturus from the handle of the Big Dipper or the plow towards Arcturus. And if you look between where Arcturus is over here and say Procyon over here, Leo is going to be in the middle, and Regulus is actually the brightest star in Leo. It's a first magnitude star, although it's on the low end of first magnitude, about a 1.4 magnitude. And to look for this particular constellation, you kind of, what I do is, first thing I do is look for the backwards question mark shape, or some people call it the sickle. And you can find it here because this is sort of be like the lion's mane, where his head is at, and then this would be his, front paw or shoulder or something. We're going to look here towards the hind legs, particularly these two stars. The tail is Denebola over here, but we're going to look at Zosma, which is Delta Leonis, but most importantly Theta Leonis, which is also known as Chertan. And if we kind of zoom in on that area, actually let's imagine that we're looking at that area to get familiar with it using some binoculars. So if we look at this area with binoculars, you can see there's Chertan right here, and then there is going to be a fifth magnitude star down here called Eta Leonis, and you'll notice that we have three galaxies right close by to there. Now it would seem like we could just do a simple star hop and go, oh, Chertan to Eta and right over there. Sure, that seems easy, except galaxies are faint. And they're not always easy to see, especially in more light polluted areas. So the more light polluted it is, the more difficult it's going to be to see these galaxies. So a couple things are going to help you. One, darker skies. So if you're looking at this, try to do it when the moon is not in the sky. You can also use averted vision, which I will talk about later, as well as another technique. But first, let's find these. So we are going to go from Chertan, and actually you can use Zosma kind of as your line. So if you've, with that 7 degrees field of view that we typically have in a finder scope, you'll be able to see Zosma and Chertan together. We're going to kind of go along that same line. That will help you get to Eta Leonis, and you'll have both those stars in the same field of view. So that's not too difficult, even though Chertan is a fainter third magnitude star because it's 3.3. And even Eta Leonis is a fainter fifth magnitude star because it's 5.3. But look for those, again, using binoculars to get yourself kind of in that area and know where to look, block any outside lights if you need to. And then here's how I find these galaxies. There is a little, what I call a fishhook shape of stars. Now, don't get off track because I know finder scopes reverse the field of view left and right and upside down for a lot of them. So you're going to see a number of stars in here that may look like you need to go in the right direction. But if you're going with Zosma to Chertan, you won't get confused. So there's this star over here, which is a 6th magnitude star. This one, which is a 7th magnitude star. We're going to the brighter one, 5th magnitude, Eta Leonis. And that's in the direction you get these fishhook stars, which is 7th magnitude and 7th magnitude, and this is a little fainter at 8th magnitude, and then this one back over here is a 7th magnitude star. You should be able to see most of those in most finder scopes of, say, 30 millimeters or larger. The larger your finder scope, the easier that's going to be to see. But once you have found those, now you're kind of in the right field of view. So you can get yourself probably right about here, or if you want to, if you can see this star, which is a 7th magnitude star, that's going to get you even closer. But let's start from over here because that's going to be our brightest, almost our brightest one that we're going to be able to start with. So if we then look through our telescope and I'm going to do it at about a 1.4 degrees field of view because 1 degree is really tight. So use your widest, longest focal length eyepiece. It's got a big apparent field of view, and then we will see this. Now, the fishhook used to be this way, and now it's this way. That's because I'm looking through a reflector telescope. Reflectors are going to tend to be the bigger telescopes that you've got available to have more aperture to be able to see these. So that's what's going to happen is this fishhook is going to look reversed. So don't let that throw you because binoculars are going to show it differently. But this will be the same configuration that you would see in a typical finder scope, provided you don't have a right angle or a correct image one. So here's this fishhook. You can see how at the end of it, we've got this double star right here. If we just kind of scoot our way over in on the fishhook side, we're going to see this star that was that one that I said that's closer to where the galaxies are. We can now kind of bring that in and say, okay, now I know the galaxies are in my field of view. Even if I can't see them, I know that they're there. But this star right here might fool you because you're going to think you're seeing the galaxy, but that's actually a 10th magnitude star. So the 10th magnitude star could mess you up. But if you see that, go ahead and center that and then start looking for the galaxies. Now here's how you do it if you're not used to looking for galaxies, because they'll be faint if you can even see them at all. And if you know you're in the right spot, you know you're there, like you've followed all my steps and you've gotten there and you're like, I see the 10th magnitude star day, but I don't see any galaxies. That's okay. Use averted vision. So averted vision is looking initially at the spot that you know that the galaxies are at, but then look away from it. But concentrate on that spot where the galaxies are. Because what happens is in the very center of the back of your eyes on your retina are the cones. Cones capture bright light during the day, and that's where you see color. However, for darker situations, our eyes evolved so that we have rods outside of that. The rods capture fainter light, and they also capture motion very well, which is important to the next thing. So because of that motion, when you look this way just a little bit, that motion will help you pick out some of that light from that galaxy, and the motion will help you to see it. So look there, look away, look there, look away, but keep focusing on that. That averted vision will help you. Another way to do that is to look at that spot and tap your telescope. Just gently, just right by your eyepiece even. You can even grab the eyepiece a little bit and just wiggle the telescope just a little bit to make the field of view move just a touch. You don't have to do it a lot, maybe like seriously this much. That's as far as you need to move it. So don't move it a lot. You don't want to be like moving the stuff out of the field of view. So move it a little bit like that. That's going to do the same thing. It activates those rods in the retina of your eye so that you can sometimes see that faint light from those galaxies because they are faint. M65 is the brightest of the three. This is actually a Leo triplet, but it's the brightest. So you can see magnitude 10.2, but that's if it was a point of light, but it's spread out. So the surface brightness is 13.3. That's getting pretty faint. M66, I'm sorry, the surface brightness of M66 is a little bit more because it's a 12.6. So don't get confused because there's that star there, but it is the slightly brighter galaxy. My apologies there. I had that reversed. But they're still somewhat faint. And then if you want to, you can come up here to NGC 3628. And that one, surface brightness of 12.8, but the magnitude is 9.5. So it's not as bright. Therefore, don't think that it's going to necessarily be brighter because that surface brightness is more. The magnitude is lower. See, we got a magnitude 9 here. That's 9.5, and this is above 9, so another 0.6 degrees of magnitude, whereas this is magnitude 10. But oddly enough, this one's a little easier to see, I think because the core is a little brighter. So here's what we can do for that. We're going to take off these. We'll zoom back in. And what I can do is I'm going to turn on, I wanted to show you the field of view without the galaxies in there, but I turned on, because I added this deep sky objects images function on stellarium. And so M65 I think has a little bit brighter core. M66 feels a little bit more spread out, but it's got that bright star, well, a 10th magnitude star near it, so it seems like there's a brighter aspect to it. But M65 to me showed up a little bit better, and NGC 3628, you can see how it's not exactly showing a lot, even though it says it's an active galaxy. These two are definitely going to be the easier ones to see. Hey, Messier saw them first back in the 1700s, and we didn't really know about NGC 3628 until much later. So that is the Leo triplet, but particularly M65 and M66 that you can see for galaxies in the spring. That's all for this week. Keep your eyes on the sky and your outdoor lights aimed down so we can all see what's up. I'm David Fuller, wishing you clear and dark skies.